Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count complete subarrays in an array. So the problem states that we are given an array nums consisting of positive integers, and we call a subarray complete if the number of distinct elements in the subarray is equal to the number of distinct elements in the entire array, and we want to return the number of complete subarrays. So if you look at this example, we return 4 because there are 3 distinct elements, and we can make a subarray with this, with this, with this, and with this, so we return 4. And if we look at this example, we return 10 because the array only has the integer 5, so any subarray is complete, and there are 10 subarrays in this array, which is 1, 2, 3, 4, 5, 6, and 7, 8, 9, and 10. So we return 10. So now that we have seen some examples, let's get to how we can solve this problem. So for this problem, if we know that this window works hypothetically, then we know that we can add as many elements to the right of it, and that will also work. So that's the intuition behind this problem. So we will be using sliding window. So distinct will represent the number of distinct elements in the array, and CNT will be the count of each element that shows up within the windows that we have. So left will represent the left pointer, and right will represent the right pointer. And we will include everything from the left pointer to the element before the right pointer. And then to update result, we will add the length of nums minus the right pointer plus 1 if we see a valid window. And we can check if a window is valid if the length of the hash map is equal to a number of distinct elements. When we see a valid window, then we will shift the left pointer, and whenever we see a window that is not valid, then we will shift the right pointer and continue adding elements to the hash map. And we will continue until both the left pointer and the right pointer have reached the end. So let's go over this example real quick. So first we see that there are 3 distinct elements, 1, 3, and 2. And then we would add 1 to the hash map and shift the right pointer. The length is not equal to 3, so we will add and shift the right pointer again. Still not equal to 3, so we will add this and shift the right pointer again. And we still do not have 3 distinct elements in the hash map, so we will add and shift the right pointer again. And now we do have 3 distinct elements, and as we can see, we can add 2 to the result because we will do length, which is 5, minus the right pointer, which is 4, and then plus 1, which will equal to 2. And as you can see, this subarray works and this subarray works. So since we have a valid subarray, then we will shift the left pointer now, and we will add 2 again in result because our hash map is still valid. And as you can see, this works and this works. So since it's valid, we will shift the left pointer again. And now the hash map does not have 3 distinct elements, so we will shift the right pointer. Now technically we would shift the right pointer, but since we have reached the end, so we shift the left pointer. And we shift the left pointer again. And now that both pointer has reached the end, we can return 4 as our result. So the time complexity would be O of n, where n is the number of elements in nums because it will take n time to shift both pointers. And the space complexity will also be O of n because the hash map can take up to O of n space. So now let's go to the coding part. So first we will initialize result to 0. Then we will set distinct to the length of the set of nums. And then we would initialize count to a counter hash map, and then initialize the right pointer to 0. Now we will loop through the left pointer. So for left, in range length of nums. And if right is less than the length of nums and the length of count is less than distinct, then we need to shift the right pointer, and we make sure we update the hash map beforehand. So count of nums of right plus 1. And then we shift the right pointer. And if the length of count happens to be equal to distinct, then we can update the result. So it would be length of nums minus right plus 1. And then we would shift the left pointer. And if count of nums of left is equal to 0, then we need to make sure we delete that element from the hash map so the length of the hash map can decrease, and then return the result. Okay, perfect. Hope this was helpful. Thank you for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.